year 1850, a British explorer named Austen Henry Layard descended into the ruins of an ancient palace in what is now Iraq. There, beneath the sands where the great Assyrian Empire once flourished, he discovered something remarkable: a library of over 30,000 clay tablets preserved by fire and time. Among them was a curious circular disc, a star map that would puzzle scholars for more than 150 years. It depicted the heavens as seen by a Sumerian astronomer over 5,000 years ago. But hidden in its wedge-shaped inscriptions was something else entirely: the eyewitness account of a catastrophe so immense, so devastating, that science struggles to explain it even today. In the year 1845, a young Englishman named Austen Henry Layard set out on a journey that would change our understanding of human history forever. For Layard had developed during his earlier travels through the ancient lands of Anatolia and Syria a deep and abiding fascination with the civilizations that had once flourished in the region known to the ancients as Mesopotamia, the land between two rivers. And now he found himself drawn irresistibly to a series of great mounds rising from the plains near the city of Mosul in what is now northern Iraq. Mounds that the local people called Kuyunjik, and that Layard suspected concealed the ruins of the legendary city of Nineveh, capital of the mighty Assyrian Empire that had once dominated the ancient world from Egypt to Persia. Between 1847 and 1851, Layard conducted the first large-scale excavations at this site, and what he discovered beneath those sun-baked mounds exceeded even his most ambitious dreams. For as his workers cleared away the accumulated dust and debris of more than 2,000 years, they began to uncover the remains of magnificent palaces that had once belonged to the great Assyrian kings. Palaces whose walls were adorned with extraordinary bas-reliefs carved in alabaster depicting scenes of royal hunts where lions fell beneath the arrows of kings, scenes of terrible wars where armies clashed and cities burned, scenes of lavish banquets where musicians played and servants poured wine for their masters, and everywhere there were inscriptions in a strange wedge-shaped script that scholars were only just beginning to decipher. A script we now call cuneiform, from the Latin word for wedge. But among all the treasures that Layard brought to light during those years of excavation, none would prove more significant in the long run than his discovery of what appeared to be a vast archive of clay tablets, thousands upon thousands of them, some intact and some broken into fragments, buried in the ruins of a palace that had belonged to one of the last great Assyrian kings, a ruler named Ashurbanipal, who had reigned in the 7th century before the Common Era. Ashurbanipal was not like other ancient kings, for while most rulers of his time concerned themselves primarily with conquest and the accumulation of wealth and power, Ashurbanipal possessed an unusual passion for knowledge and learning. He could read and write in multiple languages, including the ancient Sumerian tongue that was already by his time a dead language used only by scholars and priests. And he took it upon himself to gather together in his palace at Nineveh copies of every text he could find throughout his vast empire, sending scribes to temples and archives across Mesopotamia with orders to copy and bring back to him works of literature and science and religion and magic and medicine and astronomy and mathematics and law, creating what we now recognize as the first systematically organized library in the history of the world. The Royal Library of Ashurbanipal, as scholars now call it, contained more than 30,000 clay tablets and fragments, texts in various languages covering virtually every branch of knowledge known to the ancient world. And among its holdings were works of surpassing importance, including the most complete surviving version of the Epic of Gilgamesh, that ancient tale of a king who sought immortality and learned instead the wisdom of accepting the limits of human existence. And here we encounter one of the great ironies of history. For when the Assyrian Empire fell in 612 before the Common Era, and the enemies of Ashurbanipal's successors sacked and burned the city of Nineveh, they sought to wipe all memory of the Assyrians from the face of the earth, to destroy utterly the civilization that had for so long terrorized their ancestors. And yet, in their destruction, they inadvertently preserved the very knowledge they wished to obliterate. For when the palace walls collapsed, they buried the clay tablets beneath tons of rubble, protecting them from the elements, and the fires that consumed the city baked the soft clay hard as stone, ensuring that the words inscribed upon them would survive for millennia until Layard and his workers brought them once again into the light of day. The tablets were packed into crates and shipped across deserts and seas to the British Museum in London, where they joined the growing collection of antiquities that Victorian England was gathering from every corner of its expanding empire. And there they sat in storage rooms and display cases, their secrets locked within the mysterious wedge-shaped symbols that covered their surfaces, waiting for someone who could read them. That someone arrived in the form of a most unlikely scholar, a young man named George Smith, who worked as an engraver at a printing firm that produced banknotes, a man with no university education and no formal training in ancient languages, but who possessed an insatiable curiosity and a remarkable gift for decipherment. Smith had been swept up in the wave of popular enthusiasm for all things Assyrian that had gripped Victorian society following the publication of Layard's accounts of his discoveries, and during his lunch breaks, he would walk to the British Museum to study the tablets on display there, teaching himself to read the cuneiform script from whatever books he could find on the subject. The museum staff noticed this persistent young man and recognized his unusual abilities, and in 1861 they offered him what must have seemed a dream come true, a position at the museum where he would be paid to do what he had been doing for free, to study the tablets and attempt to piece together the broken fragments and make sense of their contents. For years, Smith labored in the museum's storerooms, sorting through thousands of tablets and fragments, fitting pieces together like an enormous three-dimensional puzzle, slowly learning to read the ancient languages inscribed upon them with ever greater fluency. And then one day in 1872, he made a discovery that would shake the foundations of Victorian religious certainty and capture the imagination of the entire Western world. He was working on a tablet from Ashurbanipal's library, a tablet that contained part of an epic poem about a legendary king named Gilgamesh, when he realized that the passage he was translating described a great flood sent by the gods to destroy humanity, a flood from which only one man and his family escaped by building a great boat and filling it with animals, a story so similar to the biblical account of Noah and the Ark that its implications were staggering. The story of a divine flood destroying the world, which Christians and Jews had believed for thousands of years to be a unique revelation from God to Moses, had been told in Mesopotamia centuries before the Bible was written, had been inscribed on clay tablets in a language that had been dead for 2,000 years, had been buried beneath the ruins of a pagan city, and had now emerged to challenge everything the Victorians thought they knew about the origins of their sacred scriptures. Smith gave a public lecture announcing his discovery in December of 1872, and such was the excitement it generated that even the Prime Minister William Gladstone attended to hear this banknote. Engraver turned scholar describe how a clay tablet from ancient Assyria had revealed that the story of Noah's flood was not unique to the Bible. The Daily Telegraph newspaper was so captivated by the discovery that it offered to fund an expedition to Nineveh to search for more tablets, and, remarkably, Smith himself led this expedition. And even more remarkably, he found among the thousands of fragments still scattered across the site the very piece he needed to complete the flood narrative, a coincidence so extraordinary that it seemed to some observers almost miraculous. But for all the attention lavished on the flood tablet and the Epic of Gilgamesh and the other literary and historical texts from Ashurbanipal's library, there were among those 30,000 tablets many objects that remained mysterious, tablets whose purpose and meaning eluded even the most learned scholars. And among these enigmatic artifacts was a small circular disc of clay approximately 5 inches in diameter and a little over an inch thick. A disc divided into 8 sections by lines radiating from its center, covered with cuneiform inscriptions and strange symbols that appeared to represent stars and constellations, an object that would come to be known as the planosphere, and that would puzzle historians and astronomers for more than 150 years. The tablet now resides in the British Museum under the catalogue number K8538, a modest designation for an object that some researchers believe may contain one of the oldest eyewitness accounts of a cosmic catastrophe in human history. When scholars first examined the planosphere, they assumed it was an Assyrian creation from the time of Ashurbanipal, a star chart or astronomical reference document made in the 7th century before the Common Era. But as techniques for analyzing such artifacts improved, and as computers became available to model the positions of celestial bodies at any point in the past, researchers began to suspect that the tablet was much older than anyone had imagined, that it was in fact a copy of a far more ancient document, a document that recorded observations made not by Assyrian astronomers in the first millennium before the Common Era, but by Sumerian stargazers nearly 3,000 years earlier, in an age so remote that the Great Pyramids of Egypt had not yet been built. The Sumerians were the earliest known civilization in human history, a people who emerged in the southern reaches of Mesopotamia during the 4th millennium before the Common Era, and who gave the world many of its most fundamental innovations, including the wheel and the plough and the sailboat and the potter's wheel and the first system of writing and the first cities and the first schools and the first written law codes and the first mathematical notation and the first astronomical records. And it was these last that made the planosphere so intriguing to modern researchers, for the Sumerians were passionate observers of the heavens, who tracked the movements of the sun and moon and planets with remarkable precision, and who developed a sophisticated understanding of celestial mechanics that they passed down to the Babylonians and through them to the Greeks and eventually to us. Unfortunately, the planosphere is not complete. Approximately 40% of its surface has been lost, damage that scholars believe dates back to the sacking of Nineveh when the library of Ashurbanipal was destroyed and its contents scattered and broken. And this missing portion has made the tablet extraordinarily difficult to interpret. For without the full text and all the symbols, it is like trying to read a book with every other page torn out, possible to get a general sense of the narrative, but impossible to be certain of the details. Yet even in its fragmentary state, the planosphere has fascinated everyone who has studied it, for the surviving portions seem to describe something far more dramatic than the ordinary nightly rotation of stars across the sky, something that moved and changed and grew larger as the ancient astronomer watched, something that did not belong in the familiar patterns of the heavens. And over the years, scholars have proposed many theories about what the tablet might depict. From comets to meteors to eclipses to unusual planetary conjunctions, none of which seem to fully account for all the details inscribed on that small disk of clay. The tablet sat in its case at the British Museum, examined periodically by curious researchers, photographed and catalogued and described in scholarly papers, but never fully understood. A message from the remote past, written in symbols we could read, but whose meaning continued to elude us until early in the 21st century, when two researchers armed with modern computer technology and a willingness to consider unconventional hypotheses decided to take a fresh look at this ancient puzzle, and in doing so claimed to have uncovered a secret that had been hidden in plain sight for more than 5,000 years. The eyewitness account of a catastrophe so immense that its echoes may still be heard in myths and legends from across the ancient world. A night when the stars themselves seemed to fall from the sky and fire rained down upon the earth and the world, as those ancient observers knew it came to a sudden and terrifying end. Long before the Greeks named the constellations, long before the Egyptians aligned their pyramids to the pole star, there were the Sumerians, and they were watching the sky with an intensity and precision that would shape human civilization for millennia to come. To understand the tablet that now rests in the British Museum, we must first understand the people who created it. And to understand those people, we must travel back more than 5,000 years to a land between two rivers, where humanity first learned to write down what it saw in the heavens. The Sumerians gave us many gifts that we still use today, without even realizing their ancient origins. But perhaps their greatest contribution was the invention of writing itself. The cuneiform script, those distinctive wedge-shaped marks pressed into soft clay that allowed knowledge to be preserved across generations and across the vast gulfs of time. This linguistic innovation emerged sometime between 3,500 and 3000 BC, and it is precisely because of this invention that we know anything at all about their sophisticated understanding of the cosmos. Without writing, all their accumulated wisdom would have vanished like morning mist over the Euphrates, leaving no trace for future generations to study and marvel at. But they did write. They wrote extensively, and among the things they wrote about most carefully were the movements of the stars and planets above their heads. Historians are certain that the Sumerians were accomplished astronomers, though much of their direct knowledge has been lost to us, leaving only tantalizing fragments of what must have been a remarkably sophisticated understanding of celestial mechanics. What we know of their astronomical achievements comes to us largely through indirect transmission, passed down to the Babylonians who inherited their lands and their learning, who expanded upon Sumerian foundations and built an astronomical tradition that would endure for centuries. The Babylonians, in turn, influenced the Greeks, and through the Greeks, all of Western astronomy, so that when you look up at the night sky and trace the familiar patterns of the zodiac, you are in some small way participating in a tradition that began in the mud brick cities of ancient Sumer. Consider for a moment how we measure circles and angles today, how we divide a full rotation into 360 degrees, how we break each degree into 60 minutes and each minute into 60 seconds. This system, so familiar that we rarely question it, comes directly from the Sumerians, who used a sexagesimal system of measurement based on the number 60. Modern astronomers still use this ancient Sumerian convention when plotting the positions of stars and galaxies, when calculating the trajectories of spacecraft, when mapping the very universe itself. Every time a scientist measures an angle in degrees, minutes, and seconds, they are unconsciously paying homage to those first stargazers who stood on the rooftops of Ur and Uruk and Eridu, watching the slow wheeling of the heavens and trying to make sense of what they saw. The devotion these ancient people brought to their observations is almost impossible for us to fully appreciate in our age of light pollution and digital distraction. From the 8th century to the 1st century before the Common Era, a span of 700 years, Babylonian astronomers observed the night sky closely and consistently, recording their observations night after night, generation after generation, in what has been called, arguably, the longest-lasting scholarly science project that ever existed. 700 years of continuous observation, 700 years of patient watching, 700 years of careful recording, all in the service of understanding the mechanics of the heavens and the possibility of making predictions from what they saw. This was not casual stargazing, but systematic science, conducted with a rigor and dedication that would not be matched in the Western world until the scientific revolution of the Renaissance. And all of this built upon foundations laid by the Sumerians, those first astronomers whose names and individual contributions are largely lost to us, but whose legacy shaped everything that followed. Now let us turn our attention to the specific type of tablet that concerns us. For the planosphere is not merely a piece of clay with some marks scratched upon it, but rather belongs to a particular category of astronomical instrument known as an astrolabe. The word astrolabe comes from Greek and means star taker, and while the Greeks would later develop sophisticated metal instruments bearing this name, the concept originated much earlier in Mesopotamia with these clay tablets that mapped the positions of stars across the sky. The Sumerian astrolabe is the earliest known astronomical instrument in human history, predating all the elaborate devices that would come later, the armillary spheres and quadrants and sextants and telescopes that fill the history of astronomy. It consists of a segmented disc-shaped star chart divided into sections like slices of a pie, with units of angle measure inscribed upon the rim, allowing the observer to note the positions of celestial objects with reasonable precision. The astrolabes are among the earliest documented cuneiform tablets that discuss astronomy in a systematic way, and they date back to the Old Babylonian Kingdom, generally considered to have been written between 1800 and 1100 BC. They contain lists of 36 stars connected with the months of the year, creating a kind of calendar written in starlight, allowing the priests and astronomers of ancient Mesopotamia to track the passage of time by watching which stars rose and set at particular seasons. But here is where our particular tablet becomes especially interesting, for the planisphere that now rests in the British Museum is not an original document from the time it describes. It is a copy, a late Babylonian reproduction of a much earlier Sumerian original created in the 7th century BC, but preserving observations made perhaps 2,000 years before that. This practice of copying important documents was common in the ancient world, and it is how so much ancient knowledge survived the fires and floods and conquests that destroyed so many original texts. The scribes of Ashurbanipal's library did not merely collect tablets, they actively copied older documents that were wearing out, or that existed only in distant archives, preserving knowledge that might otherwise have been lost forever. The K8538 tablet, our planosphere, was considered important enough to be copied and recopied over more than 2,500 years, passed down from generation to generation of scribes who recognized its significance even if they may not have fully understood everything it contained. Think about that for a moment. Think about a document so valued that it was carefully reproduced again and again across 25 centuries, surviving the rise and fall of empires, the death of languages, the extinction of the very civilization that created it. Whatever this tablet recorded, the ancient peoples of Mesopotamia believed it was worth preserving, worth the painstaking labor of copying each wedge-shaped mark by hand, worth protecting and transmitting to future generations. And they were right, for here we are, 5,000 years later, still studying it, still trying to understand exactly what that ancient astronomer saw and recorded on that long-ago night. For over a century after its discovery in the ruins of Nineveh, the planosphere remained partially mysterious, its general nature understood, but its specific content debated. Scholars could see that it was an astronomical document, could recognize some of the constellation names and understand the basic structure of the tablet, but the precise meaning of certain sections eluded them. The tablet was damaged, perhaps 40% of its surface missing, due to the destruction that accompanied the fall of Nineveh, and what remained was written in an archaic form of cuneiform that was difficult to interpret with certainty. Various theories were proposed over the decades, various translations attempted, but no consensus emerged about exactly what astronomical event the tablet might be describing. Then, in 2008, 2 British researchers published a remarkable study that would transform our understanding of this ancient artifact. Alan Bond, the managing director of Reaction Engines Limited, and Mark Hempsell, a senior lecturer in astronautics at Bristol University, brought something to the study of this ancient tablet that no previous scholar had possessed, namely modern computer technology capable of simulating the night sky as it would have appeared thousands of years ago. They subjected the planosphere to a sophisticated software program that could reconstruct celestial positions for any date in the past, allowing them to test various interpretations of the tablet's content against what the sky would actually have looked like on different nights in ancient history. What they found was extraordinary. Using these computer simulations, Bond and Hempsell determined that the planosphere is a copy of the night notebook of a Sumerian astronomer, recording the events he observed in the sky before dawn on a specific date that corresponds to June 29th, 3123 BC in the Julian calendar. Half of the tablet, they concluded, records perfectly ordinary astronomical observations, the positions of planets and notes about cloud cover, the same kind of routine data that any dedicated astronomer might record on any given night. But the other half of the tablet records something very different indeed, something that was decidedly not routine, something that must have filled that ancient observer with wonder and perhaps with fear. It describes an object in the sky large enough for its shape to be noted, even though it was still in space, an object moving against the background of stars, an object following a trajectory that the astronomer carefully recorded in relation to the fixed stars around it. The idea that a Sumerian star map could document such a precise astronomical event thousands of years before the invention of the telescope might seem far-fetched at first consideration, the kind of claim that belongs more to sensational television programs than to serious scholarship. But the evidence that Bond and Hempsel assembled is difficult to dismiss. They found that the tablet's record of the object's path was accurate to within 1 degree of modern calculated trajectories for an asteroid on an Earth-crossing orbit. 1 degree of accuracy achieved by a naked eye observer using only the most primitive of instruments, recording his observations by pressing a reed stylus into wet clay by the light of oil lamps. This was not a myth, not a legend, not a story embellished and distorted through generations of oral transmission. This was a scientific record, etched by hand in a world without telescopes, without satellites, without physics textbooks, without any of the technological apparatus we have come to associate with astronomical observation. The ancient astronomer, whom the researchers have given the name Lugalan Shegibar, meaning the great man who observed the sky, sensed the historical significance of what he was witnessing and decided to document it with all the precision at his command. He could not have known that his observations would survive for 5,000 years, could not have imagined that scholars in a distant future would use machines he could not have conceived of to verify the accuracy of his work. He simply did what astronomers have always done. He watched the sky, he recorded what he saw, and he trusted that somehow, someday, someone would find his observations valuable. And they are valuable, perhaps more valuable than he could ever have dreamed. For if the interpretation of Bond and Hempsel is correct, this simple clay tablet preserves the only eyewitness account of one of the most catastrophic events to strike our planet in recorded human history. Let us travel now to a night more than 5,000 years ago, to a time when the great cities of Mesopotamia rose from the fertile plains between the Tigris and Euphrates rivers, when the priests of Sumer climbed their towering ziggurats each evening to study the heavens and record the movements of the wandering stars. On this particular night, the 29th of June in the year 3123 BC, according to the Julian calendar, an astronomer whose name has been lost to history, but whom modern researchers have given the honorific title Lugalan Shegibar, meaning the great man who observed the sky, took his place at his observation post as he had done countless nights before, his reed stylus ready, his clay tablet prepared to receive whatever messages the gods might send across the celestial dome. The night began as any other might have begun, with the astronomer carefully noting the positions of the planets, recording the familiar patterns of the constellations, perhaps making observations about the clarity of the air or the presence of clouds drifting across certain portions of the sky. But then, something extraordinary happened, something so remarkable that this careful observer immediately recognized he was witnessing an event of profound historical significance, an event that demanded documentation with all the precision his training had provided him. Moving across the heavens, came an object unlike anything recorded in the astronomical archives of his predecessors, a brilliant apparition that the astronomer described in his notations as a white stone bowl approaching from the sky. This was no ordinary shooting star, no brief flash of celestial light that appears and vanishes in the space of a breath. This object was large enough that its shape could be discerned, even while it remained in the distant reaches of space, bright enough to command attention against the star-filled backdrop of the Mesopotamian night, and it was moving with a terrible purpose toward the Earth itself. With remarkable presence of mind, the astronomer began plotting the trajectory of this cosmic visitor against the fixed reference points of the constellations he knew so well, measuring its path with an accuracy that modern researchers would later determine to be within a single degree of precision, an extraordinary feat of observational astronomy achieved without telescopes, without computers, without any of the instruments we take for granted today, accomplished solely through the trained eye and practiced hand of a scholar who understood that what he was seeing might never be seen again. The object he tracked that night was, according to the analysis conducted by Alan Bond and Mark Hempsel, using computer programs capable of reconstructing the ancient sky, an asteroid more than 1 kilometer in diameter, a mountain of rock and metal hurtling through the void on what astronomers call an Aten-type orbit, a class of near-Earth objects whose paths around the Sun bring them into periodic close encounters with our world. This particular asteroid was not merely passing close to Earth on that summer night so long ago. It was coming down. Across the Mediterranean it streaked, no longer a point of light, but a growing fury of superheated atmosphere and incandescent stone. And the astronomer in Mesopotamia, hundreds of kilometers away, watched and recorded as this harbinger of catastrophe traced its fiery arc across the pre-dawn sky. Let us pause here to appreciate the full weight of what this ancient observer accomplished. He could not have understood the physics of what he was witnessing, could not have known about the composition of asteroids or the mechanics of atmospheric entry, or the terrible energies that would be released when this object reached its destination. What he knew was that the heavens had sent something unprecedented, something worth preserving for future generations, and so he pressed his stylus into the wet clay with all the care and precision his training demanded, creating a record that would survive the fall of empires, the burning of cities, the passage of millennia, until finally it would be unearthed from the ruins of Nineveh and carried to a museum in a city that would not exist for another 4,000 years. The destination of that asteroid, according to the trajectory recorded on the tablet and reconstructed through modern analysis, was a valley in what we now call the Austrian Alps, a place called Kufels that has puzzled geologists since they first examined it in the 19th century. There, high in the mountains of the Ötztal region, lies one of the most unusual geological formations in Europe, a mass of pulverized and displaced rock some 5 kilometers in diameter and 500 meters thick, a landscape of shattered stone that speaks of unimaginable forces unleashed in a single cataclysmic moment. When geologists first studied the Kufel site, they found evidence that seemed to point unmistakably toward an impact event of tremendous magnitude. The rocks showed signs of having been subjected to crushing pressures far beyond anything normal geological processes could explain. There were deposits of material that appeared to have been flash melted, fused by temperatures so extreme that solid stone had momentarily become liquid before cooling into strange glassy formations. By the middle of the 20th century, the scientific consensus held that Kufels must be the scar left by a massive meteor impact, one of the largest to have struck Europe in the geologically recent past. But as the study of impact sites advanced, and scientists developed more sophisticated understanding of what cosmic collisions actually look like, doubts began to emerge about the Kufels' interpretation. The most troubling absence was the one feature that should have been most prominent at any major impact site: a crater. When an asteroid strikes the Earth at cosmic velocities, the impact releases energy equivalent to nuclear weapons, blasting out a bowl-shaped depression that can persist for millions of years. The famous Barringer crater in Arizona, formed by an object far smaller than the one proposed for Kufels, remains clearly visible more than 50,000 years after it was created. Yet at Kufels, there is no crater, no circular rim of uplifted rock, no central peak, none of the characteristic features that planetary scientists have learned to associate with impact events from studying examples across the solar system. This absence proved fatal to the impact hypothesis in the minds of many researchers, and by the late 20th century, the prevailing view had shifted toward explaining Kufels as an unusually large landslide, perhaps triggered by an earthquake or by the gradual destabilization of the mountain slopes over time. The mysterious melted rocks were reinterpreted as products of friction, generated when the sliding mass of stone created enough heat through its own movement to partially melt itself. The case seemed closed, another geological mystery resolved through careful analysis and the accumulation of evidence. But the work of Bond and Hempsel suggested a different resolution, one that could explain both the absence of a crater and the presence of impact-like features at the Kufels site. The key lay in the trajectory recorded by that ancient Sumerian astronomer, the path of the Whitestone Bowl as it crossed the heavens toward its appointment with the Alps. According to their analysis, the asteroid approached at an extremely shallow angle, just 6 degrees above the horizontal, a nearly grazing trajectory that would have profound consequences for what happened next. Imagine the asteroid screaming through the upper atmosphere, heating to incandescence as air molecules slam into its surface at velocities measured in tens of kilometers per second. At a steeper angle, it would have plunged directly into the Earth, transferring its enormous kinetic energy into the ground in a single apocalyptic instant, blasting out a crater proportional to its size and leaving an unmistakable scar upon the landscape. But at 6 degrees, the asteroid was not diving, it was skimming, barely descending as it raced across the mountains of what would one day be called Austria. And there, 11 kilometers before what would have been its point of impact, stood a mountain called Gamskogel, rising into the path of the onrushing cosmic projectile. The collision between the asteroid and Gamskogel was not a direct impact, but a clipping blow, a grazing contact between a mountain of stone moving at orbital velocity and a mountain of stone rooted in the Earth. The effect was to shatter the asteroid, to break apart this coherent mass of rock and metal into an expanding cloud of superheated debris, a fireball perhaps 5 kilometers in diameter that continued along the original trajectory, but was no longer a solid object capable of excavating a classic impact crater. When this fireball reached Kufels, it did not strike the ground as a single unified mass. Instead, it arrived as a blast wave of unimaginable fury, a wall of superheated gas and fragmented stone that slammed into the valley with enough force to pulverize the bedrock and set in motion the massive landslide that geologists would wonder at thousands of years later. The pressures were sufficient to melt rock. The heat was sufficient to fuse stone into glass. But because the impactor had been dispersed before arrival, there was no central point of contact, no crater-forming excavation, just overwhelming destruction spread across kilometers of alpine terrain. The effect would have been visible from an astonishing distance. The initial flash of the Gamskogel collision, the subsequent fireball racing down the valley, the mushroom cloud of debris rising into the upper atmosphere, all of this would have been witnessed across much of Europe and the Mediterranean, a spectacle of cosmic violence that would surely have left its mark on the memories of all who saw it. But according to the researchers, the immediate destruction was only the beginning of the catastrophe. When an object of this size and velocity explodes in the atmosphere, it does not simply scatter its debris across the immediate vicinity. The physics of the explosion create what scientists call a back plume, a column of superheated material that rises high into the atmosphere and then bends back along the trajectory of the incoming object, carried by the momentum of the impact. In the case of Kofels, this back plume would have risen into the upper atmosphere and then curved back across the path the asteroid had traveled, arcing over the Alps, across the Mediterranean Sea, and descending once again as it reached the skies over the Levant, the Sinai Peninsula, and northern Egypt. What would this have meant for the people living in those regions on that morning, more than 5,000 years ago? Imagine settlements scattered across the ancient Near East, communities of farmers and herders and traders going about the ordinary business of their lives as dawn approached. Perhaps some of them had noticed the strange light in the western sky, the brilliant streak that marked the asteroid's passage overhead. Perhaps they had paused in their work to wonder at this celestial portent, to discuss what message the gods might be sending through such an unusual sign. And then the sky began to fall. The back plume of the Kofels explosion, having risen high into the atmosphere over Austria, would have re-entered the thicker air over the eastern Mediterranean as a rain of incandescent debris, fragments of the shattered asteroid and pulverized mountain stone that had been carried aloft by the explosion, and were now descending across hundreds of kilometers of settled land. This would not have been the concentrated destruction of the impact zone itself, but it would have been terrifying nonetheless, a storm of fire from the heavens that would have destroyed crops, ignited structures, killed livestock, and people with terrible indiscrimination. For those who survived, the experience would have been seared into memory with the intensity of the flames themselves, a day when the sky turned to fire and the gods demonstrated their power to destroy everything humanity had built. It is here that we must tread carefully, for we are leaving the realm of physics and geology and entering the murkier territory of mythology and speculation. The researchers who studied the planosphere tablet noted that the proposed back plume trajectory would have carried debris over precisely the regions where some of the most powerful destruction myths of the ancient world originated. The story of Sodom and Gomorrah, of cities annihilated by fire and brimstone raining from the heavens, is set in the region that would have lain beneath the descending plume. The ancient Greek myth of Phaeton, the boy who borrowed his father Helios' chariot and lost control of the horses that pulled the sun across the sky, tells of a catastrophe in which the earth itself was scorched by celestial fire before Zeus intervened to end the destruction. at least 20 ancient myths from cultures across the Mediterranean world describe devastation of a type and scale consistent with what would have resulted from such an event. Tales of fire from above, of smoke that darkened the sky, of cities and peoples erased from existence by the wrath of powers beyond human understanding. It would be irresponsible to claim that the Kofels event definitively explains these myths, that we have found the historical kernel at the heart of the Sodom story, or the Phaeton legend. Myths are complex cultural artifacts that evolve over generations of telling and retelling, absorbing new meanings and interpretations as they pass from one community to another, from one era to the next. A single catastrophic event, however dramatic, is rarely sufficient to explain the full richness of a mythological tradition. And yet the correlation is striking. The geographical alignment is precise, and the human need to make sense of inexplicable destruction through storytelling is universal. Perhaps what we see in these ancient tales is not a direct recording of the Kofels event, but an echo of it, a cultural memory that was reshaped and reinterpreted over thousands of years until it took the forms we recognize today. Perhaps the fire that fell on the cities of the plain and the flames that Phaeton loosed upon the world represent not a single historical moment, but a tradition of skyborne catastrophe that the Kofels event reinforced and revivified for generations who had not witnessed it themselves. Or perhaps the connections we see are illusory, patterns imposed by human minds that are always eager to find meaning and correlation even where none exists. What we can say with more confidence is that the Sumerian astronomer who watched the white stone bowl cross the heavens and pressed his observations into clay did not do so in a vacuum. He was part of a civilization that took the sky seriously, that watched for omens and portents, that believed the movements of celestial bodies carried messages from the divine realm to the human world. When he saw something unprecedented, something that defied all his training and experience, he responded not with paralysis, but with action, documenting what he witnessed with all the precision his culture had developed over centuries of systematic observation. That document survived because it mattered, because scribes of later generations recognized its significance and copied it carefully, preserving the ancient observation through the rise and fall of empires until it came at last to rest in the library of Ashurbanipal, where it would wait through another 2.5 millennia until Layard shoveled away the sand and brought it back into the light. We cannot know what the astronomer thought as he watched the fireball descend toward the western horizon. Whether he understood that he was witnessing destruction on a scale beyond anything his civilization had experienced, whether he felt fear or awe, or simply the calm determination of a scholar doing his duty in extraordinary circumstances. We cannot know whether news of the catastrophe reached Mesopotamia in the days and weeks that followed, whether traders brought tales of devastation from the west, whether refugees arrived bearing stories of cities erased and lands made barren by fire from above. What we know is that he recorded what he saw, and that his record has reached us across an ocean of time, a message from the deep past that may yet help us understand what happened on that June morning when the sky fell upon the mountains of Austria and scattered its fury across the ancient world. And now we must pause in our journey through the ancient past and consider something that every honest exploration of history demands of us, and that is a willingness to question even the most compelling of stories, to hold our wonder in one hand and our skepticism in the other. Because the truth is that the interpretation offered by Bond and Hempsel, as fascinating and elegant as it appears, has faced serious and substantial criticism from the scientific community, and the most significant challenge to their theory concerns something fundamental, something that strikes at the very heart of their argument. And that is the question of dates, the chronology of events. Because when geologists have examined the Kofels landslide site in the Austrian Alps, when they have taken samples of wood that was buried beneath that massive cascade of rock and subjected those samples to radiocarbon dating, the results have consistently pointed to a date far earlier than what the Sumerian tablet supposedly records, approximately 9,800 years before the present era, which translates to roughly 7,800 years before the Common Era began. And this presents an enormous problem, a gap of nearly 4,000 years between when the science tells us the landslide occurred and when the tablet claims an astronomer witnessed a fiery object streaking across the heavens. And 4,000 years is not a small discrepancy that can be easily explained away. It is a chasm of time, longer than the entire span from the fall of Rome to our present day. And so we must ask ourselves how this could be, how such careful astronomical analysis could point to one date, while the physical evidence in the Austrian mountains points to another entirely. And there are those who have suggested various explanations. Perhaps the radiocarbon dating is somehow flawed. Perhaps there were multiple events at Kofels, and the researchers have conflated two separate occurrences. Perhaps the tablet records something else altogether, a different impact in a different location that has yet to be discovered. But none of these explanations have gained wide acceptance among the broader scientific community. And we must also consider the nature of the tablet itself. For remember that the clay disc held in the British Museum was not created in 3123. Before the Common Era, when the observations supposedly took place, it was inscribed around 700 years before the Common Era in the library of Ashurbanipal, meaning it is allegedly a copy of a copy of a copy, passed down through more than 2,000 years before being set in the clay we see today. And this raises its own questions. How would a scribe in ancient Nineveh know with such precision when an event had occurred 2.5 millennia before his own time? What records would he have had access to, and how much might have been lost or altered or misunderstood in all those generations of transmission? And there is something else we should consider as well, something that speaks to the way scientific understanding evolves over time. Because the original reason that geologists in the 19th and early 20th centuries suspected that Kofels might be an impact site was the presence of something peculiar in the rocks there, a type of fused stone, melted and reformed in ways that seemed to require tremendous heat and pressure. And at the time, there were only two known processes that could produce such materials: volcanic activity and the violent collision of an object from space. But Kofels sits far from any volcanic region, and so the impact hypothesis seemed logical, even necessary. But science does not stand still, and in the decades that followed, researchers discovered something important: that the enormous friction and pressure generated by massive landslides, by millions of tons of rock grinding and sliding and compressing against itself, can also produce fused rock, and similar materials have been found at other large rockslide sites around the world, places where no one has ever suggested an extraterrestrial impact. And so, The very evidence that once seemed to demand an explanation involving an asteroid from space can now be explained by purely terrestrial processes, by the awesome power of gravity and stone. And this does not mean that Bond and Hempsel are necessarily wrong. Science is rarely so simple as that. But it does mean that the physical evidence at Kürfels no longer requires an impact to explain it. The landslide could simply be a landslide, one of the largest in the Alps certainly, but a natural geological event nonetheless. And when we step back and survey all of this, the dating discrepancy and the questions about transmission and the alternative explanations for the fused rock, we find ourselves in a position that is perhaps uncomfortable but ultimately honest, a position of uncertainty. And some critics have been quite pointed in their assessments, noting that the interpretation strays uncomfortably close to the territory of ancient astronaut theories and pseudo-archaeology, that it makes grand claims based on evidence that does not quite support them. And while this may seem harsh, it reflects a fundamental principle of scientific inquiry, that extraordinary claims require extraordinary evidence, and that we must be willing to question even the theories we find most appealing. But here is where we might pause and take a breath and consider what all of this controversy actually teaches us. Because there is something valuable in this debate, something that goes beyond whether or not an asteroid struck the Austrian Alps 5,000 years ago. And that is a lesson about the nature of knowledge itself, about how we come to understand the past, about the humility required when we peer across such vast stretches of time and try to reconstruct events that left only fragmentary traces. And the truth is that the scientists who have criticized the Kürfels impact theory are not villains in this story. They are not closed-minded skeptics refusing to see what is plainly before them. They are doing exactly what science demands. They are testing claims against evidence. They are offering alternative explanations. They are insisting on rigor and precision. And this is how knowledge advances, not through uncritical acceptance of compelling narratives, but through the patient, sometimes frustrating process of questioning and testing and questioning again. And perhaps the tablet does record an asteroid impact, just not the one at Kürfels. Perhaps somewhere in the deserts of the Middle East or the depths of the Mediterranean. There lies evidence of a catastrophe that matches the date and trajectory described in those ancient cuneiform symbols. Or perhaps the tablet records something else entirely, a spectacular meteor that blazed across the sky and burned up harmlessly in the atmosphere, a fireball so bright and so memorable that an astronomer felt compelled to preserve the moment in clay. We simply do not know. And in that not knowing, there is a kind of wisdom, an acknowledgement that the past keeps its secrets even from our most sophisticated instruments and our most creative interpretations. And so we hold the controversy gently, neither dismissing the work of Bond and Hempsel, nor accepting it uncritically, understanding that the conversation continues, that new evidence may emerge, that future scholars with tools we cannot yet imagine may finally resolve the question one way or another. And until then, we are left with what we have always had when confronting the mysteries of the ancient world, fragments and traces, and the irresistible human urge to make sense of them, to weave them into stories that help us understand who we are and where we came from, and what forces have shaped this world we inhabit. And there is something beautiful in that uncertainty, something that invites us to keep searching, to keep questioning, to remain curious about a past that will never fully reveal itself to us. There is something profoundly moving about the way stories travel through time. Long before the invention of writing, long before clay tablets or papyrus scrolls, human beings sat around fires and told each other tales of the world they had inherited. And among the oldest and most widespread of all these stories are the tales of a great flood, a catastrophic deluge that once swept across the earth and nearly destroyed everything. These flood myths appear in cultures separated by vast oceans and mountain ranges, cultures that had no apparent contact with one another, and yet they all speak of waters rising, of darkness falling, of a world unmade and then slowly, painfully remade again. The oldest known written account of such a flood comes from the very same land where our mysterious star map was created, from the ancient Sumerians of Mesopotamia, who told of a man named Ziusudra, who was warned by the gods that a terrible flood was coming, and who built a great boat to survive it. This story, recorded on clay tablets more than 4,000 years ago, predates the biblical account of Noah by at least a millennium. And yet the similarities are unmistakable. Both speak of divine warning, of an ark, of animals gathered 2 by 2, of waters that covered even the highest mountains, of a bird sent out to find dry land. The Hebrew scriptures describe rain falling for 40 days and 40 nights until the entire earth was submerged. The Babylonian epic of Gilgamesh, which drew upon even older Sumerian sources, tells of a hero who witnessed a pillar of black smoke rising on the horizon before the sky went dark for 7 days, followed by a cyclone and a flood that devastated the Fertile Crescent. In ancient India, the Matsya Purana tells of the god Vishnu appearing as a fish to warn the first man, Manu, of an approaching deluge. In ancient Greece, the myth of Deucalion and Pyrrha describes how Zeus sent a great flood to punish humanity, and only this virtuous couple survived by floating in a wooden chest for 9 days and nights. The Aztecs of Mexico told of a flood that lasted 52 years. The Hopi people of North America speak of a world destroyed by water. In China, the story of the Great Yu describes a flood that lasted for 2 generations. On and on the stories go, spanning continents and millennia, all telling of a world drowned and reborn. For centuries, scholars debated what to make of this remarkable convergence. Some argued it was mere coincidence, that floods are common enough that every culture would naturally develop stories about them. Others suggested that the myths spread through cultural contact, traveling along ancient trade routes from Mesopotamia to distant lands. But in recent decades, a third possibility has emerged, one that takes these myths more seriously as potential records of actual events. Archaeologist Bruce Mass spent years collecting and analyzing flood myths from around the world, eventually gathering 175 separate narratives from cultures on every inhabited continent. What struck him was not just their existence, but their details. Many of these myths contain specific astronomical observations that can be dated using modern computer simulations of ancient skies. 14 of the flood myths he studied make explicit reference to a full solar eclipse occurring at the time of the catastrophe. Hindu myths speak of an alignment of the 5 visible planets. Chinese myths describe comets streaking across the sky. When Masse fed these astronomical details into computer models capable of reconstructing the positions of celestial bodies, thousands of years ago, a striking pattern emerged. The details from myths spread across multiple continents all pointed to a narrow window of time around 2800 BCE, and specifically to a date of May 10th, 2807 BCE. Massa hypothesized that these myths might preserve the memory of a real cosmic catastrophe, perhaps a comet or asteroid striking the Indian Ocean and generating tsunamis that would have devastated coastal populations around the world. Such an impact would have sent walls of water crashing into shorelines from Africa to Australia, to India, to the Arabian Peninsula, and the survivors, scattered and traumatized, would have told their children and grandchildren about the day the sky fell and the sea rose up to swallow the world. But floods are not the only catastrophes preserved in myth. Fire, too, features prominently in the collective memory of our species. The ancient Greeks told of Phaeton, the reckless son of the sun god Helios, who begged his father to let him drive the chariot of the sun across the sky. Helios reluctantly agreed, but Phaeton lost control of the immortal horses, and the chariot careened too close to the earth, scorching the land and setting whole regions ablaze before Zeus struck the boy down with a thunderbolt to prevent total destruction. The Romans told similar stories of fire raining from the heavens. The Hebrew scriptures describe the destruction of the cities of Sodom and Gomorrah, where fire and brimstone fell from the sky and reduced thriving communities to ash and ruin in a single night. For thousands of years, these stories were understood primarily as moral tales, divine punishment for human wickedness. But recent archaeological discoveries have prompted some researchers to ask whether they might also preserve memories of real events. In 2021, a team of scientists published research on Tall El Hammam, an ancient city in the Jordan Valley near the Dead Sea that was suddenly and catastrophically destroyed around 1650 BCE. The archaeological evidence was remarkable. Buildings had collapsed outward, suggesting a massive shockwave. Pottery shards showed signs of having been heated to temperatures exceeding 2000 degrees. The outer layers of bricks had melted into glass. Human bones were scattered and fragmented in patterns consistent with a sudden, violent death. Most strikingly, the soil itself was salted, its agricultural fertility destroyed for centuries afterward. The research team proposed that Tal El Hammam had been destroyed by an airburst, a meteor or asteroid that exploded in the atmosphere with the force of a nuclear weapon, releasing a blast of heat and pressure that annihilated everything in its path. The salted earth, they suggested, came from the shockwave carrying minerals from the Dead Sea inland and depositing them across the scorched landscape. Some researchers suggested this event might be the historical kernel behind the biblical story of Sodom. It should be noted that this research has faced significant criticism, and in fact, the original study was retracted by the journal Nature, following concerns about errors in methodology and interpretation of the data. Science, by its nature, is a process of proposal and revision, and not every hypothesis survives scrutiny. But the broader question remains compelling. Whether or not Tal El Hammam was destroyed by a cosmic airburst, whether or not the Khufu's landslide was triggered by an asteroid, whether or not a comet struck the Indian Ocean in 2807 BCE, the possibility that some of our oldest and most widespread myths preserve genuine memories of catastrophic events deserves serious consideration. The emerging field of geomythology studies precisely this intersection of legend and geology, seeking to identify the real natural disasters that may lie behind stories passed down through countless generations. What this research reveals is something profound about human memory and human storytelling. We are, it seems, a species that remembers. Even without writing, even without formal historical records, our ancestors found ways to encode crucial information about the dangers of the world and pass it on to their descendants. A flood myth is not just a story. It is a survival manual wrapped in narrative. It tells future generations that the waters can rise, that the world can be destroyed, that only those who heed the warnings and prepare will survive. A fire from heaven myth does the same for cosmic dangers, reminding us that destruction can come without warning from above. These stories may have been distorted and embellished over millennia, their specific details lost or transformed, their scientific content wrapped in the language of gods and heroes. But at their core, they may preserve something precious, the lived experience of our ancestors, their terror and their survival, their desperate need to make sense of catastrophe and to warn those who would come after. When we read these myths today, whether in a Sumerian cuneiform tablet, or a biblical scroll, or a collection of indigenous oral traditions, we are not just encountering ancient literature. We may be listening to the voices of survivors, echoing across thousands of years, still trying to tell us what they saw. The Sumerian astronomer who recorded the star map we have been discussing, if the interpretation is correct, was doing exactly this. He saw something terrible in the sky, a massive object hurtling toward Earth, and he felt compelled to write it down, to make a record that would survive him, to ensure that his observation would not be lost. And somehow, against all odds, through the rise and fall of empires, through conquest and burning and burial and rediscovery, his record did survive. It reached us. We are still listening. This is perhaps the most remarkable thing about the human story, not that catastrophes happen, but that we remember them, that we tell stories about them, that we carve those stories into clay and stone and carry them in our hearts across the generations. Every myth is a message in a bottle, cast into the ocean of time by someone who hoped it would reach the distant shore of the future. And here we are, on that shore, picking up the bottles and trying to read what is inside. We owe it to those ancient voices to take them seriously, to consider that behind the gods and heroes and supernatural elements, there may be something real, something that actually happened, something that changed the world. The stars have fallen before, the waters have risen, fire has rained from the sky. Our ancestors knew this, and they did everything in their power to ensure that we would know it too. Their myths are their gift to us, a reminder that the universe is vast and sometimes violent, and that survival depends on watching, on remembering, and on passing what we learn to those who come after. There is something profoundly moving about the way stories travel through time. Long before the invention of writing, long before clay tablets or papyrus scrolls, human beings sat around fires and told each other tales of the world they had inherited. And among the oldest and most widespread of all these stories are the tales of a great flood, a catastrophic deluge that once swept across the earth and nearly destroyed everything. These flood myths appear in cultures separated by vast oceans and mountain ranges, cultures that had no apparent contact with one another, and yet they all speak of waters rising, of darkness falling, of a world unmade and then slowly, painfully remade again. The oldest known written account of such a flood comes from the very same land where our mysterious star map was created, from the ancient Sumerians of Mesopotamia, who told of a man named Ziusudra, who was warned by the gods that a terrible flood was coming and who built a great boat to survive it. This story, recorded on clay tablets more than 4,000 years ago, predates the biblical account of Noah by at least a millennium. And yet the similarities are unmistakable. Both speak of divine warning, of an ark, of animals gathered 2 by 2, of waters that covered even the highest mountains, of a bird sent out to find dry land. The Hebrew scriptures describe rain falling for 40 days and 40 nights until the entire earth was submerged. The Babylonian epic of Gilgamesh, which drew upon even older Sumerian sources, tells of a hero who witnessed a pillar of black smoke rising on the horizon before the sky went dark for 7 days, followed by a cyclone and a flood that devastated the Fertile Crescent. In ancient India, the Matsya Purana tells of the god Vishnu appearing as a fish to warn the first man, Manu, of an approaching deluge. In ancient Greece, the myth of Deucalion and Pyrrha describes how Zeus sent a great flood to punish humanity, and only this virtuous couple survived by floating in a wooden chest for 9 days and nights. The Aztecs of Mexico told of a flood that lasted 52 years. The Hopi people of North America speak of a world destroyed by water. In China, the story of the Great Yu describes a flood that lasted for 2 generations. On and on the stories go, spanning continents and millennia, all telling of a world drowned and reborn. For centuries, scholars debated what to make of this remarkable convergence. Some argued it was mere coincidence, that floods are common enough that every culture would naturally develop stories about them. Others suggested that the myths spread through cultural contact, traveling along ancient trade routes from Mesopotamia to distant lands. But in recent decades, a third possibility has emerged, one that takes these myths more seriously as potential records of actual events. Archaeologist Bruce Mass spent years collecting and analyzing flood myths from around the world, eventually gathering 175 separate narratives from cultures on every inhabited continent. What struck him was not just their existence, but their details. Many of these myths contain specific astronomical observations that can be dated using modern computer simulations of ancient skies. 14 of the flood myths he studied make explicit reference to a full solar eclipse occurring at the time of the catastrophe. Hindu myths speak of an alignment of the 5 visible planets. Chinese myths describe comets streaking across the sky. When Massa fed these astronomical details into computer models capable of reconstructing the positions of celestial bodies thousands of years ago, a striking pattern emerged. The details from myths spread across multiple continents all pointed to a narrow window of time around 2800 BCE, and specifically to a date of May 10, 2807 BCE. Massa hypothesized that these myths might preserve the memory of a real cosmic catastrophe, perhaps a comet or asteroid striking the Indian Ocean and generating tsunamis that would have devastated coastal populations around the world. Such an impact would have sent walls of water crashing into shorelines from Africa to Australia to India to the Arabian Peninsula, and the survivors, scattered and traumatized, would have told their children and grandchildren about the day the sky fell and the sea rose up to swallow the world. But floods are not the only catastrophes preserved in myth. Fire, too, features prominently in the collective memory of our species. The ancient Greeks told of Phaeton, the reckless son of the sun god Helios, who begged his father to let him drive the chariot of the sun across the sky. Helios reluctantly agreed, but Phaeton lost control of the immortal horses, and the chariot careened too close to the earth, scorching the land and setting whole regions ablaze, before Zeus struck the boy down with a thunderbolt to prevent total destruction. The Romans told similar stories of fire raining from the heavens. The Hebrew scriptures describe the destruction of the cities of Sodom and Gomorrah, where fire and brimstone fell from the sky and reduced thriving communities to ash and ruin in a single night. For thousands of years, these stories were understood primarily as moral tales, divine punishment for human wickedness. But recent archaeological discoveries have prompted some researchers to ask whether they might also preserve memories of real events. In 2021, a team of scientists published research on Tall el-Hammam, an ancient city in the Jordan Valley near the Dead Sea that was suddenly and catastrophically destroyed around 1650 BCE. The archaeological evidence was remarkable. Buildings had collapsed outward, suggesting a massive shockwave. Pottery shards showed signs of having been heated to temperatures exceeding 2000 degrees. The outer layers of bricks had melted into glass. Human bones were scattered and fragmented in patterns consistent with a sudden, violent death. Most strikingly, the soil itself was salted, its agricultural fertility destroyed for centuries afterward. The research team proposed that Tall el-Hammam had been destroyed by an airburst, a meteor or asteroid that exploded in the atmosphere with the force of a nuclear weapon, releasing a blast of heat and pressure that annihilated everything in its path. The salted earth, they suggested, came from the shockwave carrying minerals from the Dead Sea inland and depositing them across the scorched landscape. Some researchers suggested this event might be the historical kernel behind the biblical story of Sodom. It should be noted that this research has faced significant criticism, and in fact, the original study was retracted by the journal Nature, following concerns about errors in methodology and interpretation of the data. Science, by its nature, is a process of proposal and revision, and not every hypothesis survives scrutiny. But the broader question remains compelling. Whether or not Tall el-Hammam was destroyed by a cosmic airburst, whether or not the Khufu's landslide was triggered by an asteroid, whether or not a comet struck the Indian Ocean in 2807 BCE, the possibility that some of our oldest and most widespread myths preserve genuine memories of catastrophic events deserves serious consideration. The emerging field of geomythology studies precisely this intersection of legend and geology, seeking to identify the real natural disasters that may lie behind stories passed down through countless generations. What this research reveals is something profound about human memory and human storytelling. We are, it seems, a species that remembers. Even without writing, even without formal historical records, our ancestors found ways to encode crucial information about the dangers of the world and pass it on to their descendants. A flood myth is not just a story. It is a survival manual wrapped in narrative. It tells future generations that the waters can rise, that the world can be destroyed, that only those who heed the warnings and prepare will survive. A fire from a heaven myth does the same for cosmic dangers, reminding us that destruction can come without warning from above. These stories may have been distorted and embellished over millennia, their specific details lost or transformed, their scientific content wrapped in the language of gods and heroes. But at their core, they may preserve something precious, the lived experience of our ancestors, their terror and their survival, their desperate need to make sense of catastrophe and to warn those who would come after. When we read these myths today, whether in a Sumerian cuneiform tablet or a biblical scroll or a collection of indigenous oral traditions, we are not just encountering ancient literature. We may be listening to the voices of survivors, echoing across thousands of years, still trying to tell us what they saw. The Sumerian astronomer who recorded the star map we have been discussing, if the interpretation is correct, was doing exactly this. He saw something terrible in the sky, a massive object hurtling toward Earth, and he felt compelled to write it down, to make a record that would survive him, to ensure that his observation would not be lost. And somehow, against all odds, through the rise and fall of empires, through conquest and burning and burial and rediscovery, his record did survive. It reached us. We are still listening. This is perhaps the most remarkable thing about the human story, not that catastrophes happen, but that we remember them, that we tell stories about them, that we carve those stories into clay and stone and carry them in our hearts across the generations. Every myth is a message in a bottle, cast into the ocean of time by someone who hoped it would reach the distant shore of the future. And here we are, on that shore, picking up the bottles and trying to read what is inside. We owe it to those ancient voices to take them seriously, to consider that behind the gods and heroes and supernatural elements, there may be something real, something that actually happened, something that changed the world. The stars have fallen before, the waters have risen, fire has rained from the sky. Our ancestors knew this, and they did everything in their power to ensure that we would know it too. Their myths are their gift to us, a reminder that the universe is vast and sometimes violent, and that survival depends on watching, on remembering, and on passing what we learn to those who come after. Imagine him now, that unnamed astronomer standing on the roof of a temple, or perhaps a simple mud brick tower somewhere in the vast flat expanse of ancient Sumer. The night air cool against his skin, and the sky above him blazing with more stars than any of us will ever see in our modern light-polluted world. And in his hand, he holds a lump of wet clay still soft and yielding, and beside him rests a reed stylus sharpened to a fine wedge. And something extraordinary is happening in the heavens above him, something he knows instinctively must be recorded, must be preserved, must be passed down to those who will come after. And so he presses the stylus into the clay with careful, deliberate strokes, creating the wedge-shaped marks we call cuneiform, recording the positions of stars and planets, and that strange bright object streaking across the firmament. And he cannot possibly know, cannot even begin to imagine, that the clay beneath his fingers will outlast empires, will survive the fall of Sumer and the rise and fall of Babylon and the glory and destruction of Assyria, will be buried beneath the sands for thousands of years, and then unearthed by strangers from a land he never knew existed, will be carried across vast oceans to a city called London, where it will rest in a great museum, will be studied by scholars using tools and techniques he could never have dreamed of. Computers that can reconstruct the very sky he watched that night. And his words, his careful observations, will speak across 50 centuries to people who live in a world utterly transformed, yet who still look up at the same stars with the same wonder and the same burning need to understand. And perhaps this is the true legacy of that ancient astronomer. Not the answers he may or may not have provided about asteroids and impacts and catastrophes, but the questions he embodied, the eternal human impulse to watch and wonder and record, to reach across time with our observations and say to those who come after us that we too stood beneath these stars. We too marveled at the heavens. We too tried to make sense of this vast, mysterious cosmos in which we find ourselves. And so the stars continue their ancient journey across the sky. The same stars that shone over Mesopotamia shine still. The same constellations wheel overhead tonight that wheeled overhead 5,000 years ago. And somewhere right now, someone is looking up, just as that Sumerian astronomer looked up, feeling that same sense of smallness and wonder and connection to something far greater than themselves. And in that act of looking, in that moment of shared wonder across all the centuries, we are never truly alone.